the order of which these evaporated from the fastest to evaporate to the slowest. Hexane was the first to evaporate, followed by our ethyl acetate second, and then our methyl alcohol, and lastly is our ethyl alcohol. So this shows us which force is the weakest, intermolecular force is the weakest to the strongest. And so if we look at our first to evaporate, CH4, our hexane, was insanely fast to evaporate, but this is made of nothing but C's and H's. And when you have something that's nothing but C's and H's, even though it's a larger molecule, this is nonpolar. And when it's nonpolar, it's going to be a dispersion force. If we look at second to evaporate, now we have a larger molecule. Okay, that could explain why it was second to evaporate versus hexane, but it's the biggest molecule of them all. And so it's not necessarily the size. So we look at the intermolecular force, the strongest intermolecular force. This portion here is nonpolar because nothing but C's and H's. This portion here, nothing but C's and H's. This portion here, nothing but C's and H's. So that's all nonpolar. So we got to find out, like, is there anything else going on? Well, we have right here, we have this OCO group. And so anytime we have different elements in a molecule, especially an oxygen, well, oxygen is going to be bonded to a carbon here. So this is going to be a polar molecule. Okay, so this is a polar, which means a dipole, which therefore explains, move that there. If you have a polar molecule, a dipole is stronger in intermolecular force. So that explains why this was second to evaporate versus the hexane. So we look at the other ones. Okay, which one was third? Now this one is third to evaporate, but it's the smallest. What does it have that is making it stay a liquid longer? Well, if we look at it, CH3 group, that's going to be a nonpolar area. But here we go. We have an O and an H. So that H is directly bonded to that oxygen. So that's an H bond. Well, how many do we have? There's only one. So we have one H bond. All right, so we come over here to our one to evaporate last. And so we look at our structure, CH3, nonpolar, CH2, nonpolar, O attached to an H. Well, that's an H bond. Well, that's pretty bad there, but we can fix it maybe. H bond. Well, there's one H bond. Well, these are equal in their intermolecular force. They both have hydrogen bonding, but one evaporates quicker. Okay, our methyl alcohol evaporated before our ethyl alcohol. So why, if they have equal numbers of H bonding, like water, for example, up at our first part, water had two hydrogen bonding versus our isopropyl alcohol only having one, and that explains why it evaporated second versus isopropyl. But if we have the same number of hydrogen bonds, why does this one evaporate last compared to this one? What has to do with the number of electrons? This one's when you have an equal, a tiebreaker, a tiebreaker. Both have hydrogen bonding, both have equal numbers of hydrogen bonding. Why does this molecule here evaporate last? It's because it's got more electrons. In the molecule, it's got more electrons. When you got more electrons, you're going to have more intermolecular force.